Students, welcome to Excel Tuition, and this is part 3 of the science lesson Carbon and its Compounds for Standard 10. So let us start with the formula and structure of a saturated compounds of carbon and hydrogen. Alkanes. Let us see the table. First column is number of carbon atoms, names of the compound, formula CnH2n plus 2, and the structure and electron dot structure. First, methane. Formula is CH4. In methane, carbon is bonded with the 4 hydrogen with a single bond. That means here 4 electrons of carbon shared with the 4 electrons of hydrogen. Second is ethane, C2H6. C2H6. Hydrogen and carbon share their 1 electrons to form the electron dot and cross structure. Propane, formula is C3H8. C3, carbon atom and the hydrogen atom are bonded with a single bond. And this is the electron dot and cross structure of propane. Then butane, formula is C4H10. Here C4 and hydrogen atoms are bonded by a single bond. That means 1 electron of carbon is shared with 1 electron of hydrogen. Butane, C5H12. Here 5 carbon atoms share the electron with the hydrogen atoms. And this is the electron dot and cross structure. Next is hexane, C6H14. Here 6 carbon and 14 hydrogen are bonded with a single bond, and this is the electron cross and dot structure of hexane. Now let us see the structure and formulae of alkenes. Name of carbon atom, name of the compound, formula CnH2, and structure and electron dot structure. Ethene, C2H4. Here 2 carbon atoms are bonded with a double bond. That means here a pair of electrons is shared between the 2 carbons, hence double bond is formed. Same way propene, C3H6, C3. In these 2 carbon atoms, double bond is formed. The shared pair of electron is shown by the crosses. Butane, C4H8. Here 4 carbon atoms are bonded, and the last pair between the 2 carbon atom is bonded by double bond. This is the dot and cross structure of butene. Pentene, C5H10. Here 5 carbon atoms are bonded with 10 hydrogen atom single bond, and their carbon is bonded by a double bond. This is the electron dot and cross structure. Last carbon atom where they share the 2 pairs of electrons. Hexene, C6H12. This is the electronic structure of hexene, dot and cross structure. Now let us see the structures of alkynes. Number of carbons, name, formula CnH2n minus 2, structure and electron dot structure. Methane has 2 carbon atoms. Carbon and carbon share the 3 pairs of electrons. So here in alkynes, triple bond is formed. Propyne, C3H4. This is the electronic structure of propyne, and this is the electron dot structure. This 4 carbon is butane, C4H6, C3. After third carbon there are triple bonds, and the 2 carbon atoms share their electrons to form triple bond. It is shown in the electron dot structure as a 3 crosses, that is 6 crosses. Then pentane, C5H8. This is electronic structure, and this is electron dot structure. Then hexane, C6H10. We have to draw it same way as butane. This is the electron dot structure of hexane. Now we'll see the nomenclature of functional group. In this column there are functional groups, prefixes or suffixes which we use to name the compound, and the example of the compound. So halogens. Halogens means chlorine, bromine, iodine, etc. are called halogens. Chlorine atom is shared with the compound, then chloro. If it is bromine, then bromo. These prefixes are used. So this is a chloropropane. If bromine is added, it becomes, the name of the compound becomes bromopropane. Next is alcohol. For alcohol we use suffix ol. So this becomes propanol. And aldehyde suffix is al. So this compound named as propanal. For ketone, suffix used is one. So after the name of the compound we add one, that is propanone. Carboxylic acid suffix is oic acid. So this is propanoic acid. Then double bond or alkenes, suffix is -ine. So if this is propane, it is propene. This becomes propene. Triple bond or alkyne, suffix is -yne. Here it will become propyne. Now let us see how to identify the compounds, whether it is alcohol, aldehydes, ketones, etc. Halogens can be identified whether the compound contains chlorine, iodine, bromine, etc. Functional group in alcohol is OH. Then in aldehydes the functional group is CHO. In ketones, C double bond O is a functional group. So carboxylic acid, COOH, is the functional group in carboxylic acid. Double bond or alkene. In alkenes, double bond is between the two carbon atoms, and in alkynes there is a triple bond between the two carbon atoms. State the difference between saturated hydrocarbons and unsaturated hydrocarbons. There is a single bond between the carbon atom. There is a double bond or triple bond between the carbon atom. Second, only substitution of atoms is possible and reaction is called substitution reaction. Atom can be added across a double or a single bond and the reaction is called addition reactions. Burns with a clean non-sooty flame and burns with a yellow sooty flame. Next is alkanes and alkenes. In alkanes, single bond between the carbon atom, and in alkenes, double bond between the carbon atom. General formula of alkane is CnH2n plus 2, and general formula of alkenes is CnH2n. See, alkenes and alkynes. Alkene have a double bond between the carbon atom. Alkynes have a triple bond between the carbon atom. General formula of alkenes is CnH2n and general formula of alkynes is CnH2n minus 2.